Hello, Terry Dabba here again. Today we're going to be solving trig equations. So everybody get your unit circles out because they're going to be very, very helpful in learning how to solve trig equations. Remember, my own agenda is to make math easy. So let's begin. Solving trig equations. First of all, there's several methods. You're going to solve these trig equations just like they were linear equations or maybe quadratic equations. You will recognize they're a trig equation versus an identity or an expression because you will see an equal sign. Use whatever method works, solve for your x. When you get your x, you're not going to have just one solution because you have to think about in these trig functions, it can be that value at more than one solution. So within that interval, there could be more than one. Also, we have to consider that since the trig function repeats in a wave-like pattern, each of these solutions that we find will have infinite solutions. Think about that they're going to go around the unit circle more than a couple times, or either that period is just going to repeat. It's almost like drawing your trig graph over and over and over and over again. Okay, how do you show that? How do you show this infinite solution concept? Okay, we do know that sine of x is 1/2 at pi over 6 and 5 pi over 6. You can see that there on the unit circle. So how do you show that there's infinite solutions? Well, the way you do it is you say that x is equal to these things plus the period of sine is 2 pi, and then we're going to multiply that times n. N meaning that we're going to repeat that period over and over again infinitely many times. Okay, let's try one. This particular one, 3 sine x plus 1 equals sine x. We're going to solve this one by combining like terms. You'll recall when you're combining like terms, you do get everything on the same side. So I am going to get everything on the same side by taking that sine x, carrying it over here to the left. When I do that, it becomes negative. Just set it equal to 0. I'm going to combine like terms. These go together, and I'm given 2 sine x plus 1 is equal to 0. I'm going to subtract my 1. So I have 2 sine x is equal to negative 1. Divide by 2. And I have that sine x is going to be equal to negative 1/2. I'm going to say right now, pause your video, look at your unit circle, and see where in the world do you see sine x equal to negative 1/2. When you think you have your answer, hit play. Don't forget, sine has a period of 2 pi, and you have to compensate for that infinity. X is going to be equal to 7 pi over 6 is where we will find that. And I'm going to add my infinite. And you will also find that at 11 pi over 6. And then add my 2 pi in. Okay, let's try another one. Okay, in this one, we're going to solve this one by square root method. In square root method, you'll recall that we have to get everything away from that squared. So I'm going to first start by moving my 1 to the other side. So now I have 3 cotangent squared x equals 1. I divide by my 3. So I have that cotangent squared x is equal to 1/3. Okay, to get rid of a squared, you take the positive and negative square root of the other side. I am going to split that so that when I simplify this, I get that cotangent x is equal to 1 over the square root of 3. Okay, first of all, that's not on my unit circle because it's not going to be. We can't have a radical in the bottom. So we do have to fix that by multiplying by 1. Let's see if you remember this skill. And I will get that cotangent x is equal to positive and negative 1 square root of 3 over 3. Okay, pause your video and see if you can find all of those places. All right, so this value of x is equal to pi over 3 plus pi times n. And also you will find this at 4 pi over 3. Why am I using pi? Why did I not use 2 pi like in my last example? Look at my hint. And remember what I said, you use the period of the trig function, and cotangent has a period of pi. Okay, let's try another one. Okay, this one we're going to solve by GCF. You'll see that I do have a greatest common factor of cosine. I factor my cosine out, and I'm left with cosine squared x minus 1. Set that all equal to 0. Solving this, I have 2 factors, so I set them equal to 0. I'm going to pull this one down because I don't really have to do much manipulating there. That one's already solved. Over here, minus 1 equals 0. If I add 1 to both sides, I get that's equal to 1. I have the square root property that just came up. So I have positive and negative square root of 1. So that now gives me cosine of x is equal to plus and minus 1. So I have 3 places where I have to find my values. Okay, pause the video, look at your unit circle, and see if you can find those locations. Okay, I have found those locations at x is going to be equal to pi over 2 plus 2 pi n. X is also going to be equal to 3 pi over 2 plus 2 pi n. X is also going to be equal to pi, and I have to keep going around the circle or another period, and I also am going to find that at 2 pi, and then I also keep going. Okay, that's a lot of answers. You can write it like that, but if you think about that, that is all of the quarters of the unit circle. That's all the quarters of the unit circle. So there is one easy way to put every bit of these together, because really, since that is just the quarters of the unit circle, if I take that quarter being the pi over 2, and I multiply that times every single n that I can find, I will compensate for all of those different answers that I just got. Interesting. Both ways are correct. Just another way to write it. Okay, let's try another one. Okay, I can't solve this one because it's not set equal to 0. So I'm going to pull my 2 over and write a quadratic equation. And you will see this one's solved by AC method. My A is 1. So I put my parentheses and factor it. Secant squared will factor to secant secant. My values will be 2 and 1. I have to think about what will add to give me negative 1 and what will multiply to give me negative 2. So therefore, my signs will be minus plus. I do have 2 factors that I have to set equal to 0. And secant x plus 1 is equal to 0. take my constant to the other side, and I am left with secant x equals 2 and secant x equals -1. Okay, look at your unit circle, find your values. When you think that you have the answer, hit play. Okay, so x is going to be equal to pi over 3. Secant has a period of 2 pi. I will also find a location at 5 pi over 3. And I will also find a location at pi. Okay, let's try another one. Okay, I already see a problem. Yeah, it looks hard, but the biggest problem is that my terms don't match. I have a secant and I have a tangent, so I have to think about those trig identities, and I'm going to change secant squared into tangent squared x plus 1. Continue to write the rest of my formula. -3 is equal to 0. Okay, obviously the left side can use a little bit of combining like terms and simplifying. Distributive property first. So 2 tangent squared x plus 2. I'm going to do it step by step so you can see everything done out. Okay, I do have some like terms here. So I will be left with 3 tangent squared x minus 1 is equal to 0. We obviously have to get tangent squared by itself. So by doing so, I will get that tangent squared x is equal to 1 over 3. Here again, I have my square root property. So tangent x is equal to positive and negative square root of 1 over square root of 3. You have the same issue that came up before in a problem that you just saw earlier in this video. And so we will multiply by our radical 3, and you will get positive and negative radical 3 over 3. Okay, pause your video, see if you can find all those locations. Hint, there is 4 of them. Okay, so my x is going to be equal to pi over 6. Tangent has a period of pi. I also find a location at 5 pi over 6. I find another one at 7 pi over 6. And another one at 11 pi over 6. 4 locations. And don't forget, tangent has a period of pi. All right, let's try another one. Okay, this one's very similar to the one that we just did because they're not in the same function. Okay, so I'm going to change that cosecant to sine. Plus 1 over sine is equal to 0. Okay, to solve this equation, we do not have a common denominator. So we have to think about what is missing in that first term. And what's missing in that first term is a sine. So if I multiply that first term times a sine, that's now going to give me 2 sines. Okay, I carry my 1 to the other side. I divide by my 2. And then I will have that sine squared x is equal to negative 1/2 over 2. Don't forget it's negative because I carried this positive 1 over. I do square root property. Looks easy. Square root of the other side. problem is, can you get a square root of a negative? No, can't happen. So this equation actually has no solution. Will not work. I hope you enjoyed the video on solving trig equations. Be sure to hit subscribe so you can hear about some new exciting ways that I will do my best to make math easy. And remember, you can follow me on Twitter at Math with David. Thanks for viewing.